All right, in this example, I'm going to balance another redox reaction, but this time I'm going to use base as my medium, so it has a little bit different process. The example I have is CrO2 minus plus ClO minus makes CrO4 minus 2 and the chlorine ion Cl minus. First step I'm going to do is I'm going to figure out the charges on my ions to figure out what's being oxidized and what's being reduced. I have my chromium, my CrO minus 1, so it's a -1 overall. I know each oxygen is going to give me a -2, so that gives me a -4. So in order to get the -1 charge, my chromium has to be a +3. So I'll go ahead and write that in there so I can see it and reference it later. The chlorine, my overall charge is -1, each oxygen is -2, so this is going to become a +1. This one's a little more complex, I'll write this one out for you. So the overall charge is -2. There are 4 oxygens, so that gets me -8. That means that my chromium has to be a +6. And then the chlorine ion is right there shown for us to see. Alright, so go ahead and make it so that we can see these a little bit more clearly and not get confused. Alright, for first step, we need to break it into our half reactions. We have the CrO2 minus converting into the CrO4 minus 2, and we have the ClO minus converting into the Cl minus. After you do that, we need to make sure that all of our atoms are balanced. We have 1 chromium, 1 chlorine, 1 chlorine, so that one's fine. And we now are at the step where we need to find the electrons. So we have a +3 on this and a +6. In order to make that balance, we are going to need some electrons on this side. We have a difference of 3 electrons. And in the second reaction, we have a +1 to a -1. So we're going to need 2 electrons on the left side. So if you go back to oil rig, and if you were asked to identify if it is oxidized or reduced, this one is losing electrons, so that one's oxidized, and this one is gaining reaction, so this is reduced. But again, this is not part of the question, you're just balancing it today. Okay, so let's balance our electrons. We have 3 and 2, so the multiple would be 6. So we're going to multiply this reaction by 3 and this reaction by 2. And I'm going to go ahead and rewrite it to help make it a little less confusing and make sure that I distribute my factors in. I have 2 CrO2 minuses and 2 CrO4 minus 2s and 6 electrons. The second line gives me 6 electrons and 3 ClO minus and 3 Cl minus. Okay, so now this is the part where we need to realize that it is in base. So we are going to go through the process balancing for a base. First step in this line, we have to decide where the oxygens are needed. We have 4 oxygens on this side and we have 8 on this side, so we need additional oxygens on this side, and because it's a base, we're going to add OH ions, and we need 4 more hydroxides because we need 4 oxygens. But when you're doing base, you have to do double, so we're going to put in 8 hydroxides. Okay, let's go ahead and get the second line, the second half. We have 3 oxygens on the left, so we will need more oxygens on the right, and again we do double, so it's going to be 6 OHs. Alright, the next step is to balance the hydrogens, and we're going to balance that by adding water. We have 8 hydrogens on this first half reaction and no additional hydrogens anywhere else, so I will need to have 4 water. So the hydrogens that we added over here, we're going to balance with additional waters. The reason we added double the oxygen is because every time we add water, we bring in an additional oxygen. So second half reaction, we need 6 hydrogens balanced. So on this side, we're going to have 6, nope, not 6. We're going to have 3 water. Okay, sorry about the mistake. 3 water. Now we have balanced all of our atoms, and we should be to the part where we are going to be able to cancel and combine. Let's go ahead and cancel. We can and should cancel all of our electrons. There should be no electrons left transferring. We have 4 waters on the right and we have 3 waters on the left, so we're going to cancel that and reduce this number to a 1. We have 8 hydroxide on the left and 6 hydroxide on the right, so we're going to cancel this one and reduce this to a 2, and I believe everything else is canceled as needed. So now we're going to combine it. We're going to have 2 hydroxide and 2 CrO2 minus and 3 Cl minus, making 2 CrO4 minus 2 plus 3 Cl ions and 1 water. So this one, you can see we've had some canceling and some reducing, and we ended up with this as our balanced equation in base for that particular reaction.